And this is Algebra 1, and this is the quick review, systems of linear equations. So there's just some background information on systems of linear equations. So first thought is you have to remember and understand that the solution is a point of intersection. So the solution to the system is the point of intersection. And there are really three possibilities. When there is a point of intersection, meaning there is a solution, we'll call it consistent, and because that solution is a single point, we'll call it independent. So consistent is the fact that there is a solution, and independent the fact that there's a single point solution. And therefore, again, the solution is negative 2, 1. And don't forget what the negative 2, 1 represents, right? The negative 2 is the x value, and the 1 is the y value. So negative 2 is the x, and 1 is the y. All right, and so consistent and independent. Well, there's another possibility, and that's when they are both the same line. So they're both the same line. So in this scenario, you have to understand that every point along the line is a solution, right? Because they intersect at every single point. And so really there's an infinite number of points along the line that's the actual solution. Okay, so because there is a solution, we're going to say consistent, but because there are an infinite number of solutions, we're going to say dependent. So consistent and dependent. And to say the solution, you have to simply name the line. So you give the equation of the line, and that is the solution. And again, the line represents all the x, y values, right, that make the equation true. And so when you give the solution for consistent and dependent, you have to give the equation of the line. This equation is in slope-intercept form, right? It could be in standard form as well. We've given it in slope-intercept form. All right, so those are two of the three possibilities. Here's a third possibility, and that's the fact that you have parallel lines. Parallel lines. Well, two lines that are in the same plane that do not intersect obviously do not intersect, right? That's the definition of parallel lines. So they don't intersect, so there is no intersection. So there is therefore then no solution. So because there's no solution, we say inconsistent. Remember, consistent means there's a solution. So inconsistent, no solution. And again, how would you say that? You'd say no solution. You could use the null set symbol, right? There is no point of intersection. So there are three possibilities with systems of linear equations. The lines intersect at a point, be consistent and independent. Make sure you give the coordinates of the point as a solution. The lines are the same line, therefore it's consistent. We have a solution, but dependent, and you write the solution as the equation of the line. And then if the lines are parallel, then they are inconsistent. There is no solution.